In the last video, we looked at the different rules for addition of vectors: triangle rule, parallelogram rule, also polygon rule. We also saw how triangle rule, parallelogram rule are one and the same. Also polygon rule, triangle rule being the same. In today's video, we are going to see how to calculate the magnitude and direction of the resultant vector. So we have two vectors, vector A and vector B. Okay, what I've depicted in here, don't forget the notations. This is the magnitude of vector A because we have this vector inside the modulus sign, also vector B. So this is the magnitude. So B, modulus of B is this long, modulus of A is this long. So we have two vectors A and B, and they are inclined at an angle theta with respect to each other. Forget about this phi for now, don't pay attention to this, although it's there in the picture. But theta, remember, is the angle between the two vectors A and B. So what are the things that we know? This is given to us, this is something we know, B is something we know, and theta is what we know, the angle between the two vectors. So what we do next is we construct our parallelogram, okay, and we name the parallelogram. MNOP is the parallelogram. So what parallelogram rule tells us is, if we have two vectors starting from a point, okay, then the diagonal of the parallelogram starting from the same point, which is this, which is point M, gives us the resultant. So R happens to be a resultant. So R is vector A plus B. So A plus B, vector A plus B is another new vector, remember that. But we are going to calculate its magnitude. So M and OP is our parallelogram, and MO is our resultant. So that is exactly what I've written over here. M and OP is a parallelogram. MP, this is another notation, okay? This is another notation for vectors. MP with an arrow sign. So MP, this is a vector MP is the same as vector A. Vector MN is the same as vector B. Now what we need to do is, we need to do a bit of a construction, okay? And the construction goes like this. So MNOP is our parallelogram. What we've done is we've produced MP. We've produced vector MP or vector A up to point D, and we've dropped a perpendicular on MP produced from point O. So we've dropped a perpendicular. So OD is the perpendicular that we've dropped on MP produced, and MP itself is produced up to point D. So this is the small, construction that we are doing, because of which we get this triangle POD. Okay, this is the triangle that we are getting. So that is a small bit of construction that we have done. So MNOP is our parallelogram, MNOP is our parallelogram, MP is vector A, vector MN is vector B, MO is our resultant vector, which is vector A plus vector B, and theta is the angle between the two vectors A and B. This is something that I've already told you. So what I've done is I've only drawn this triangle over here, POD, the triangle. I've only taken the triangle POD and I've drawn it over here, POD. So see, in this parallelogram, if this is B, if this magnitude MN is B, then PO should also be B, should also have the same magnitude B. If this is magnitude A or vector A, this is also vector A having magnitude modulus of vector A. Okay, and if this angle is theta, then this angle also has to be equal to theta. Angle OPD has to be equal to theta. Alright, so I've taken the triangle POD and I've drawn it over here. So POD is the triangle. This PO is modulus of B, has length or magnitude modulus B, and this angle is theta. Now what we want to do is, we want to find how much the magnitude of PD is, also that of OD. We want to find the magnitude or the length of OD and PD. Okay, and what we get to see is PD is modulus of B cos theta, and OD is modulus of B sin theta. Now how do we get this? Okay, let me do it over here. So say for example we want to find PD. So look at this triangle POD. POD is a right angle triangle. I already told you OD is the perpendicular dropped. So POD is a right angle triangle. So for any right angle triangle, we can write cos theta. This is theta, this angle is theta, don't forget. Cos theta is the ratio of base and hypotenuse. Okay, so the base in this triangle is PD, and the hypotenuse is PO is the hypotenuse. So hypotenuse is modulus of P. Okay, so therefore what is PD? PD is B cos theta. This is how you get it. Okay, so PD is B cos theta, remember. Likewise OD. So in this triangle, OD is the perpendicular. So the trigonometrical ratio that includes the perpendicular and the hypotenuse is sine theta. So which is perpendicular by hypotenuse. Okay, so therefore perpendicular is OD, hypotenuse is modulus of P. So therefore OD is B sine theta. Alright, so this is how we get OD is B sine theta. Okay, so always remember, if any one of the sides, be it the hypotenuse, be it the base, be it the perpendicular, if any one of the sides of a right angle triangle is given to you and the angle is given, one of the angles is given, this of course being right angle, if this is given, then you can find the other lengths, other sides, the length of the other sides also. Remember that. So because of this, what we have is PD is B cos theta and OD is B sine theta. Alright, therefore MD. Now what is MD? MD is this length. We already know MP is, the length of MP is A. Okay, modulus of A of course. And PD we just now we found PD is B cos theta. And this OD is B sine theta, remember that. So how much is MD? MD will be MP plus PD, which of course is A plus B cos theta. So that is exactly what I've written over here. MD is A plus B cos theta. Okay, since MD is MP plus PD. Now remember, for my convenience, since it's so much of a problem for me to go on saying modulus of vector A plus modulus of vector B cos theta, I'll simply say, if I'm only talking about the magnitudes of the vector, I'll simply say A plus B cos theta. Remember that. Okay, and if I only have to write the modulus of the vector, I'll also do that like this. Rather than going on putting the vector inside the modulus sign and writing the arrow, I'll simply write A plus B cos theta. So if I do so, okay, understand this point very, very clearly. If I do so, remember, you need to understand, I'm only talking about the magnitude of the vector A, magnitude of vector B. Okay, cos theta in itself, of course, is a scalar. All right, so I don't have to care about its direction. But when I write A plus B cos theta, you have to understand I'm only talking about the magnitude part of the vector. Remember that. Okay, so these are the things that I could calculate because of the construction that we have done. Okay, so these are things that we know. So A was already given to us, B was already given to us, theta was already given to us. Okay, now what we also know is, we know PD is B cos theta, we know, OD is B sine theta, and therefore MD is A plus B cos theta. Up to here we know because of the construction that we've done. So how do we calculate the magnitude now? That's the real question. Okay, so in order to calculate the magnitude of this vector, we want to calculate the magnitude of MO, vector MO. Vector MO is the resultant, so we want to calculate its magnitude. So in order to know its magnitude, look at this triangle, right angle triangle. Okay, listen to me carefully. Let us look at this right angle triangle MOD. MOD is a right angle triangle. All right, and also now let us look at this angle phi. All right, so what is this angle phi? Phi is the angle. Phi, remember, is not given to us. This is something that we are supposing. Theta is given to us, yes. Phi is not given to us. Phi is something that we need to calculate. All right, we'll talk about that later on, but still for now let me tell you, phi is the angle, as you can see from the picture, that the resultant vector makes with our vector A. Phi is the angle which the resultant vector makes with our vector A. All right, so since we also want to calculate the direction, eventually we also want to calculate the direction of the resultant vector. So therefore, if we can find phi, if we can find this angle phi at which the resultant vector is inclined with respect to vector A, okay, then we know the direction of our resultant vector also. Why? Because we've already mentioned, we already know that vector A and vector B, it's given to us. It's given to us meaning we already know the direction and the magnitude of vector A. We already know the direction and magnitude of vector B. So if I can find this phi, if I can find the angle at which the resultant vector is inclined with respect to a vector A, which we, or whose direction and magnitude we already know, then we also know the direction of a resultant vector. Okay, so in order to calculate direction, we have to find phi, remember that. Okay, so in order to calculate now the magnitude, let us look at MOD, right angle triangle MOD, which for you all I have drawn over here also. MOD is this triangle. Okay, this angle is phi, this is a resultant R whose magnitude we want to calculate. OD we know is B sine theta, and MD is A plus B cos theta. Okay, so in a right angle triangle, one of the most famous formulae or theorem that we know is something called the Pythagoras theorem, which tells us that the hypotenuse squared is P squared plus B squared, perpendicular squared plus B squared. Okay, and it is exactly the hypotenuse that we want to find. We want to find the modulus of the resultant vector. So modulus of R squared from Pythagoras theorem, this is what we want to calculate, is equal to P squared. P is B sine theta, we already know. So the square of this, so B sine theta squared plus base squared. Base is A plus B cos theta, so it is A plus B cos theta whole squared. Alright, so H squared is P squared plus B squared. So R squared is B squared sine squared theta. So instead of modulus of B squared, I'm only writing B, remember. So you need to understand I'm only talking about the scalar. I'm only talking about the magnitude of the vector. Okay, so this is B squared sine squared theta from here plus A plus B whole squared. I have to open this up, and the formula that we use is A plus B whole squared. So what is A plus B whole squared? It is A squared plus B squared. B is B cos theta, so B squared cos squared theta. I have a small cos squared theta written over here. Okay, actually I had missed that cos squared theta out. Okay, so I have later on included it. So B squared cos squared theta plus 2AB. 2AB is B cos theta, so 2AB cos theta. Or R squared is rearranging A squared plus, I can take out B squared common from here. So B squared taken out common, so inside the bracket we have sine squared theta plus cos squared theta left over here plus 2AB cos theta. Okay, and we know sine squared theta plus cos squared theta is how much? Sine squared theta plus cos squared theta is 1. We already know that. Okay, so then after, what do we have therefore? So R squared is A squared plus B squared, because this thing is 1, sine squared theta plus cos squared theta is 1, plus 2AB cos theta. Or R is square root of A squared plus B squared plus 2AB cos theta. So this is the expression, remember. R means only the magnitude of the resultant vector, and these are all magnitudes. Okay, to write this equation technically correctly, okay, it should be this. Technically correct way of writing this equation, this expression is this. R is modulus of R is square root of modulus of A squared plus modulus of B squared plus 2AB, 2 modulus of A into modulus of B cos theta. Okay, but even if I write only this, you will see this written in textbooks also. So in that case, you need to understand, okay, we are only talking about the magnitude of the vector. Okay, you need to understand that, remember. So this is the expression or equation that you use to calculate the magnitude of the vector. So if A is given, the magnitudes of the vectors are given, okay, and the angle between the vectors, it's given to you, then you can easily calculate the magnitude of the resultant vector using this expression. Alright, okay. Now one thing I want you to remember, this derivation that you've done, I just spoke about the construction part and all these things, all these details, Pythagoras theorem and all these things, you will not be asked in the exam, remember. Okay, this is only for your understanding, how we land up at the eventual formula to calculate, eventual equation to calculate the magnitude of the resultant. Okay, this is only for your understanding. What you need to remember is, of course, this, the final expressions. Either this or this, it's the same thing. Okay, so the formula or the equation to calculate the resultant, the magnitude of the resultant rather, is this: square root of A squared plus B squared plus 2AB cos theta. Alright, so remember this. Next, the direction. How do you, so we've calculated the magnitude now. Okay, now to calculate the direction, I've again drawn the same thing, same picture. Okay, two vectors a, b. All right, now I've already spoken about this vector phi. I mean, not vector, this angle phi. Okay, we already know the magnitude and direction of vector a. Okay, so if we can find this angle phi at which our resultant is inclined with respect to this vector a, then we know the direction of vector, the resultant vector also, because we already know the direction of vector a. Okay, so in order to find the direction, what we do is we again consider the same triangle MOD, the right angle triangle MOD. Now in this right angle triangle, we can write tan phi. Okay, tan phi is what? Perpendicular by base, that is OD divided by MD. Okay, so tan phi is OD divided by MD. Now OD we know is B sine theta. This OD is B sine theta. So B sine theta divided by MD is A plus B cos theta. As you can see, this is A, this is B cos theta. So A plus B cos theta is MD, which can also be written, although not technically correct, which can also be written this way: B sine theta divided by A plus B cos theta. Many a times you will see it written this way. Also maybe in textbooks, you'll see in textbooks also B sine theta divided by A plus B cos theta. So therefore phi becomes how much? Phi will be tan inverse of B sine theta divided by A plus B cos theta. Now I know you are not familiar with something called this tan inverse. Okay, you are familiar with tan theta, sine theta, cos theta. You are not familiar with tan inverse theta. I mean tan inverse, sine inverse, cos inverse. You are not familiar with that. This is called inverse transformation, which you'll maybe study in class 11 itself. Okay, it's something like this. Say for example, AB is x. Okay, I can write B is x upon A. So this can also be written as x A inverse, or I can also write this as A inverse x. Okay, I can also write it this way. But remember, so it's something like this here. So tan phi, say for example, tan phi is x. So phi will be x upon tan, okay? Or phi can also be written as tan inverse of x. Only thing is, we cannot write it as x tan inverse like we did over here, x A inverse. You cannot do this. This is not correct. Okay, you can only write this tan inverse x. And this is only for your understanding that I'm doing this. Actually, you don't have this step at all in mathematics. This step is a wrong step. This is not there in mathematics. Okay, so whenever you see something like this, tan phi is x, say for example, phi can be written as always tan inverse of x. Because remember, sine, cos, tan are all operators which operates on an angle. Okay, they are operators. Tan, sine, they operate on angles. And tan inverse or sine inverse or cos inverse likewise, also they are operators which operates on some numbers. When tan inverse, sine inverse, cos inverse, they operate on a number, you get an angle. Okay, I know it will be difficult for you to grasp this. Okay, for now, let us just stop over here. Phi is tan inverse of B sine theta divided by A plus B cos theta. For now, just stop over here. Okay, just try to understand this. Okay, we'll work out some problems in the next video, and perhaps you'll understand as we progress forward. Okay, you'll understand these things in a better way. All right, so for now, I think it's more than enough for you all today. Again, give a look at this video one more time. All right, and do remember, most important thing that you need to remember today is this: how you get the resultant, the equation for you use to calculate the resultant, and this, either this or this. Okay, this is how you, from here we can find the angle. So once we find the angle, we know the direction of the resultant. All right, I'll make another video where we will be solving one problem based on this. Okay, then after, things will be more clear for you. Okay, so this much for now. Thank you.